Hey everyone, welcome to our first video about the classification of all living things. This week you're going to have two videos. The first one's going to go over naming organisms and a little bit about classifying them, and the second one will get a little bit more in depth with classifying them. So let's talk about naming. So naming organisms is really important because we want to accurately call a certain organism by its proper name. But there are two different ways to call an organism. One is the common name and one is the scientific name. With the common name, it's what we call an organism if you were to just see it, like it's what everyday people call organisms. But the thing is that those names can change greatly depending on what language you speak, what country you're in, what region of a different country you're in, and things like that. So, for example, if I was at the beach and I saw a fin, I might yell shark because I grew up speaking English and my family speaks English. And so, if I was at the beach with my family, I would yell shark. But if I was at the beach with some of my friends who speak Spanish, I might yell tiburon. And in both cases, I mean an animal with a fin and big teeth. But in English, you would say shark. In Spanish, you would say tiburon. And that's what can be tricky about common names. Common names change depending on what language you're using or what country you're in or what region. And you can see an example of that here with the cat. In English, we call that a cat. In Spanish, it's gato, chat in French. A lot of different languages have different words to describe this one animal. And those are all common names. So all these names, cat, cot, bili, mao, cat, chat, gato, those are all common names. And that's what people, everyday people, call that animal. But if someone was to publish an article in a research paper about this animal, they would want scientists from all over the world to be able to know that they had published the research and understand the research. And so they would need to use a name for this organism that is used by scientists all over the world, no matter what language. And it's based in actually Latin language. So for this organism right here, it would be universally or all throughout the world known to scientists as Felis catus. And if somebody published a research paper about cats, they would want to use the name Felis catus because people from all over the world would be able to do a Google search and find that there is an article published about that organism and then be able to translate that article into whichever language they're using. So you can see a difference there. Cat is a common name in English. Felis catus is a scientific name. For another example, common name, great white shark, and scientific name, Charcharodon charcharius. So if I were to publish a research paper about great white sharks, I would not refer to them as great white sharks. I would call them Charcharodon charcharius. Here's some practice for you. So what name can change greatly depending on the language spoken in a certain area? That's the common name. What name is used by scientists everywhere? That's the scientific name. Poecilia reticulata is an example of a what name? That's a scientific name. In English, we call this a guppy. It's a type of fish, just a guppy. But the scientific name that scientists everywhere would recognize is Poecilia reticulata. All right, how about Madagascar hissing cockroach? That's an example of what kind of name? That's a common name. And Madagascar hissing cockroach is just what we happen to call those animals in English. Okay, so what is the scientific name? Well, we call it binomial nomenclature, which means two-name naming system. So binomial, bi means two, like a bicycle has two wheels, two-name naming system, binomial nomenclature. It's developed by a scientist named Carolus Linnaeus in the 1700s, and we still use it today. When you do binomial nomenclature, you are making a scientific name, and you need to use a genus and a species, which are two categories of how we look at organisms. But the first name is the genus, and the second name is the species name. It's always written in italics. You can see that here in the example. It's slanted, it's in italics. And the first word is always capitalized, big letter, and the second word is always lowercase with a small letter. So Charcharodon, Charcharius. Charcharodon is the genus of this organism, and Charcharius is the species of this organism. Charcharodon charcharius is the scientific name. It is written with two words, the genus and then the species, in italics, and the first one is capitalized and the second one is lowercase. You can see some other examples there. So, who created binomial nomenclature? That was Carolus Linnaeus. What is the way of naming living organisms in a two-part name? What is the fancy word for a two-name name? There's examples there below. That's binomial nomenclature. In binomial nomenclature, first is the blank and then is the blank. So first comes a certain word and then second comes a different word. The first is a genus and the second is a species. So first is the genus and then is the species. And this is written how it should be. The first one's capitalized, the second one is lowercase, and it's in italics. All right, what font is used for scientific names? Look at that list of fonts. Think about it. It's italics. So just like number 2 here. All right, why do we classify living things into different categories? Well, we estimate that there are actually 8.7 million species on the planet. That's a lot of organisms. Well, classification lets biologists name and group the organisms in a way that is logical. And if you think about it, we as humans, we really like to be organized. Like our grocery stores are organized into different aisles, like there's the bread aisle and the milk aisle. Our music is organized by different genres, like there's rap music and there's jazz music and there's hip hop music and there's classical music. The kitchen is organized. Usually people keep like forks and knives in one drawer and they might keep plates in a different place. And team sports are organized. Like in football, for example, not everybody's the quarterback. There's a quarterback and then there's linemen and there are receivers. And so people are categorized all the time. So we classify a lot of things to be organized, and classification in biology lets us do that. So just like you could classify where you live, we classify living things. So like, for example, if you classify where you live, well, you live on the continent of North America and you live in the United States and you live in Virginia and you live in Salem City, which is near Roanoke County. And you might live on a certain street number and you might have a certain house number. And that's how people could classify where to send mail to you. And it gets more specific as you go. So see, continent, North America is very general, and your exact house number is very specific. Well, the same is true with classifying living things. We have things like kingdom, phylum, class, order, family, genus, and species. And species is actually the most specific. Just like when talking about where you live, the house number that you live in is the most specific. So what lets biologists name and group organisms in a logical way? That's classification. Now, taxonomy. You might have heard this word, you might have not. It is not taxidermy, which is stuffing dead animals, but this is taxonomy and it means something else. It means classifying organisms and assigning each organism a universally accepted name. So putting animals and plants and fungus and protists, all those types of living things into different categories and naming them. And within taxonomy, we have many different taxa. And the taxa are just categories. And an example of a taxa is species. Another example is genus. Another example of a taxa is family. And then we have order and class and phylum and kingdom. So the taxa are grouped together because of similarities between the organisms that are in those taxa. You'll see that here in a minute. So what is the science or study of classification and naming? That's taxonomy. A category or a group is called a taxa. And you can see there are different taxa here, like kingdom, phylum, class, order, family, genus, species. Class is one taxa, and this class is called Mammalia. This class taxa of Mammalia does include elephants, lions, foxes, wolves, and dogs. They're all mammals. They're all in the same class, but they're not all in the same order or family or genus or species. So something to think about. All right. Carolus Linnaeus gave us not only naming of organisms, but also a system for classifying organisms. And he gave us kingdom, phylum, class, order, family, genus, species. But in recent years, we've also added domain to our classification system. So we have domain, kingdom, phylum, class, order, family, genus, species. And a way to remember that is daring kings play cards on fat green stools. Kind of silly, but it has the first letter of each of those words, like domain, kingdom, phylum, class, order, family, genus, species. So that little funny sentence could help you remember this. But what you can see is it gets much more specific as you go. So the domain includes a lot of different types of organism. The kingdom gets a little more specific. Phylum gets more specific. Class gets more specific. Order gets more specific. Family gets more specific. Genus gets more specific. And species gets the most specific. So, question, you might want to be able to list the following in order. So just think about that for a second. And then you can pause the video if you'd like and see if you could write them down in the right order without looking. But if you need to rewind and look, you may. And check your work. And just so you know, like I said before, each group gets smaller and more specific. So like domain is the least specific and species all the way down here is the most specific. And each group is just getting smaller and more specific as you go. So question, which taxonomy group is the least specific? Well, that's the domain. Which taxonomy group is the most specific? It's the smallest one there. That's species. And think about this one. Which animals are more closely related? You can look in the chart, but you can also just look at their names. Is it Canis rufus and Canis lupus, or Canis rufus and Vulpes zedra? So if we look at the chart, we can see Canis rufus and Canis lupus there. And then we could see Canis rufus and Vulpes zedra. And whether you like to look at it visually and see that these guys are all coming from the same origin species, or look like visually up here, all these ones are coming from the same possible common ancestor, or if you prefer to look at the names, this has the same genus as this one. This has a different genus than this one. So which ones are more closely related? Probably the ones that have the same genus. So actually Canis rufus and Canis lupus are the most closely related because they have the same genus. Thanks for listening. Next, you'll hear a little bit more about taxonomy.